All right, so this little mini recording is just to help you see what you're doing in week one, to give you a heads up. So I went ahead and I copied some questions from week one. I hope this helps you in ensuring how you approach this homework. And so the gist of this particular assignment covers most of chapter one, which is just getting you fresh into some definitions. So you notice that each of these questions, there's 3 questions here, A, B, and C, and they're relating to quantitative versus categorical data. So it's very simple. Categorical data, think of it like qualitative data. Notice how they have qualitative here. And that refers to something that is more of a description, such as a color or the hue of a specific item. So I may be looking at a banana, and they ask me, well, describe the banana. So some qualitative variable descriptions that I would give are categorical in nature. I would say, well, the banana looks like it's yellow turning into sort of brownish because it's becoming mature. I can say things like, it's a small banana or a medium banana. It's about, those are measures, or not measures, those are descriptions that are just not non-numerical would be the word. In terms of that same banana, I can actually look at it and say, that banana is a small banana. In my opinion, I think this is about a, say, 7-inch in length. I could say it in inches, centimeters, what have you. In that case, I'm talking about potentially a measure. So in this case, quantitative, as in a quantity. I could also say it's also thin, so it's not a dense fruit. So I could say in terms of weight, I would estimate, maybe that might weigh, 14 ounces or something. I don't know. I'm sort of making up some numbers. But when it comes to weight and length of something, I'm measuring. So that's quantitative in nature. So the first thing we're going to do is we're going to analyze these in terms of quantitative or categorical. So the amount of fluid in ounces of coffee in a cup dispensed by a vending machine, well, that's definitely quantitative. Because I'm talking about ounces, that's something that I measure, it's not something I describe. Color vision status. Are you colorblind or not colorblind? Again, this one is categorical because it's going to be the nature of the question, or the answer or the response you would get would be categorical. As far as temperature in degrees Celsius, in that case, we're talking about something quantitative in nature. So that's the first, which identifies the type of variable. So we have variables that either are numerical or non-numerical, basically. Numerical, we talk about quantitative. Non-numerical, we would talk categorical, as in a category, which is an example in B. Now, the second thing they ask you to describe in this case are the levels of measurement. They are listed in the order of importance, least important to most important. So nominal is the least important of the levels of measurement, because the only thing you can take away from the nominal data is, in terms of central tendency, would be the mode. The mode is consistent in all 4. So the nominal ordinal interval ratio, you can obtain the mode, which basically is the one that occurs with the most frequency. Nominal data, since you cannot quantify it, you cannot obtain a mean, you cannot obtain a median, because I cannot add, for example, if I asked you a question, such as what is your favorite car, right? Or what car do you currently own? Let's go with that one. What car do you currently own? When you describe your car, like if you ask me, what car do you own? I would say, well, I'm a Nissan girl. I trust Nissan cars, so I've always had a Nissan. Currently, I own 2. I own an Altima, and I actually also own a Mazda 6, which is the touring, really nice car. and I also own a Murano. So you cannot tell me that you can quantify, as in obtain a median relative to what I just answered. So I cannot add up my Altima, my Mazda, and my Murano and divide them by 3 and say, well, those 3 divided by 3 equal, Mercedes. You know what I mean? It doesn't make sense. So that's nominal data. Nominal data, again, the least important of the levels of measurement. The second one in rank, in terms of least importance, is ordinal data. When I talk about ordinal data, it's kind of like you guys are in college, and I can label you as a freshman, a sophomore, a junior, or a senior. In other words, there is a rank to your current position. In high school, we would say freshman, sophomore, junior, senior. Again, a rank. If I were given a survey at a restaurant and somebody said to me, would you rate the level of service, received at your current, at this current location? And they would have, some sort of numerical rank from 1 through 5 usually, where 1 needs improvement and 5 would be excellent, and everything in between. And so that would be an example of ordinal level of measurement. Now, what is interesting about the ordinal level of measurement is that relative to the central tendencies, the mean, the median, the mode, the ordinal, you can obtain a median. So you can have a median, but you cannot have a mean. So keep that in mind. So for nominal, in terms of central tendency, I can take the mode. Ordinal, I could take the mode, and I can also find a median by putting it in order, lowest to highest, and finding the center. Okay, the next two of importance, in terms of importance, are interval and ratio. Ratio is the best, or the most important level of measurement. Interval, the difference between interval and ratio is that in interval, 0 is a possible score. So for example, if I'm talking about temperature, there is such a thing as 0 degrees. So 0 degrees, as far as interval ratio is concerned, is part of the answer choices. It's not like temperature starts at 0. Temperature can be negative, as many of you are experiencing when it gets really cold and it snows. It could also be positive. Here in Florida, we're always in the 90s. It's rare that we're in the 70s and 60s, so I am enjoying this time of year. In, say, Michigan's already been in the negatives, right? So I'm sure that they had to have passed 0 at some point. So that is the difference between interval and ratio, where ratio is or has a starting point of 0. So think of ratio like when you step on that scale to weigh yourself. You cannot you cannot weigh -1 pounds or negative any pounds. If you do, I don't know where you are, but that is not possible. Here on Earth, we start from 0, which means basically there's an absence of that material, up to positive infinity. That's the difference between interval and ratio. Now, the difference between interval and ratio and the other two, the nominal and ordinal, is that interval and ratio, as far as the central tendencies, you can obtain a mean. That's why they have the most relevance. So both of these, you can use the mean or the average of, or take an average of. You can say average temperature, for example. So for ratio, you can say the average amount of the weight is. All right. And so now relative to this question here, it says the amount in fluid ounces of coffee in a cup dispensed by a vending machine. So if I'm looking at fluid ounces, I'm looking at ratio data, because I either have no coffee or I have coffee. There's no such thing as I have negative coffee. I'm not rating it, so it's not ordinal. I'm not necessarily describing it because I'm talking about in fluid ounces. That's something I measure. And again, it's not interval because there's no such thing as negative coffee, right? When it comes to color vision status, are you colorblind or are you not colorblind? Well, that's only categorical, so therefore nominal. So nominal, not name, right? And lastly, as I described earlier, as far as temperature, when you think of temperature, I want you to remember that this is interval data. All right. You can check it. Let's see if Dr. B made any mistakes. Looks correct to me. Yay. All right. And now we move on to the next question. Now in question number 2, we need to answer, in a recent phone survey, people were asked to take or to state their favorite type of television show. So they're referring to categories such as drama, comedy, news, other, sports, and documentary. It says the pie chart below shows or summarizes the responses of those surveyed. So I want you to think of a pie chart, and I want you to break it up into quarters, so that'll help you assess these values. And some of these are a little tricky. I very well may get some of these percentages wrong, and only because, I mean, you're trying to guesstimate, right? So it says, which category was chosen by approximately 1/3 of those surveyed? So look at this circle, and I'm thinking this is about 1/3. I'm thinking this is about 1/3 because look at just this and maybe do a little penciling around it. Look at this part. This could be another third. This could be another third. So I'm thinking drama is about 1/3 of the responses. So approximately what percent of those surveyed chose other or drama? Okay, so it says write your answer as a multiple of 10%. That is 10%, 20%, 30%. So I would say 30%. Says they're adding drama to this. Now I'm starting to wonder, maybe 35%? Dare I say that? We'll see, and we'll play with this one. The only reason I'm saying that is that if I were to say 25%, you know what, let's be safe. Let's go with 30. If 10%, if sports is 10%, approximately what percent chose news? I'm looking at the sports. Look at the segment from here to here. That's supposed to represent 10%. I'm going to go with 20% for news, because if I broke this in half, I'm thinking that's 20%. Let's check our answer. The one I really doubt is this one. Let's see. Yeah, see, B is questionable. So approximately what percent of those surveys chose other or drama? So I guess I have to add. So if sports is approximately 10%, what would we dare change that to? So it's not going to be like 30%. Let's go with 35, which is what I initially wrote. Let's see what this says. I'll recheck it. Oh, this is embarrassing. Okay, so let's go then with 40%. They don't want the 5. All right, we recheck that one again, and 40% is the winner. So oddly enough, I think they're considering this about 33% in this, since it's a chunk of the 10% based on what they said. So I guess if you add that, it'll raise you to 40%, but you're kind of rounding because they're saying approximately what percent. So you see, and mind you, I've done this question a gazillion times, and I'm kind of modeling for you the way I want you to approach this. Don't be shy. All right, continue. Now we're looking at question 3. Okay, we're back to that pie. The pie chart below shows how the annual budget for a certain company is divided by department. So research department is 30%, sales is 20%, you get the idea. They're saying there's a total budget of $50 million because we all, we deal with these big numbers all the time. What amount is budgeted for support, media, and research combined? So support, I have 27%, And write that down on your paper. Media, we have a little 3%. So that's a total of 30% so far. And now we add the other 30%, which is research. So I have a total of 60%. They want to know what is 60% of 50 million. So take a calculator and put in 0.3 because we're going to change, or 0.6 because we're going to change. We're going to change that that value to a. I'm looking for my calculator. So instead of 60%, we're going to write 0.6 because we're going to divide 60% by 100. And that times 50 million, chump change. I've got that in my account right now. Well, that account is now 30 million of my 50 million is what's budgeted for this account. So basically I multiplied 0.6, which is adding the 3% to the 27% to get 30%, plus 30%, 60%. Take 60 divided by 100. That'll give you the 0.6 that I was referring to. And then take that 0.6 and multiply it by 50 million. And your answer on your calculator should be 30 million. Okay, chump change. All right, so we'll check that and see how we did. We are correct. All right, and that applies to any one of these. You multiply the decimal equivalent times the total budget, and that should give you that value. All right, I'm going to finish this question. I've got to hop into a meeting. So this is really nice. A nice bar chart, basically comparing CDs, DVDs, video games, products, and radios. And they're comparing 2 years. So you notice 2019 is in red, 2020 is in striped green. So it asks you here, which products sold more in 2019 than they did in 2020? So, and check all that applies. So we're looking at this being bigger than this. And if you notice, we have CDs, DVDs, and radios. So CDs, DVDs, and radios. All right, and notice this one, no, because this one, the green is higher than the red, right? Which products had more than 800 sold in 2019? More than 800. So here's 800, and we want more than, so obviously DVDs. These are at 800, so I guess our answer is only DVDs. Everything else is below. Lastly, estimate the number of radios sold in the 2 years. So in terms of radios, see how that's 600? I would argue that that's like 550 because 500 would be slightly in the middle. So that would be the middle, that's 500. So I would say 550 plus 400, I would say 950. Okay, again, if you are only looking at radios and you're noticing this hits the line, that's 400. 600 is here. This is not the middle. The middle would be about here. So I would estimate that to 550, not 500. So 550 and 400, 950. And again, we check. Okay. And lastly, number 5, let's see what we have for question 5. So I want you to understand this is a stem and leaf plot. The stems that we have are 1, 2, 3, and 4. These are leaves. They're all in order. So we call this a stem and leaf, an ordered stem and leaf. So when they ask you this question, notice they say that there are 16 new cars. So you have 14, 21, 22, 22, 26, 28, 31, 31, 32, 35, 37, 37, 39, 41, 45, 48. That's the 16 cars. So when we interpret this, it asks what is the highest fuel efficiency in the sample overall. So highest fuel efficiency, and it looks like 48. So 1.4 means fuel efficiency of 14 miles per gallon. This is 48 miles per gallon. What is the lowest fuel efficiency in the 30s? Well, in the 30s, the lowest fuel efficiency is 31. You would just put 31. By the way, just FYI, the highest fuel efficiency in the 30s is 39. The lowest fuel efficiency in the 40s is 41. The highest in the 40s is 48. Do you see where I'm going with this? How many cars in the sample have fuel efficiencies in the 10s? Only one. Only one car has fuel efficiency in the 10s because there's only one number, 14. All right, let's check this and let's see if there's any errors. No, we're good. All right, so that's how you're going to approach the first part of your assignment. I'll do the rest in another video.